Good day, everyone. I hope that you're doing great today. In the previous discussion, you have learned the existence of the limits of a function and defined the derivative using the limit process involving the slope of the tangent line to a curve. And the derivative allow you to understand further the graph of a function in terms of its rate of change. However, finding the derivative of a function to the limit can be a lengthy process. So today, we will apply the differentiation rules in computing the derivative of the algebraic functions. And I hope that at the end of the lesson, you'll be able to achieve our learning target, which is basically to apply these basic differentiation rules in solving for the derivative of the given function. Okay, so let's start. Our first differentiation rule is a constant rule, and it states that the derivative of a constant function is 0. So say for example, our given function here, f of x is equal to 100. Basically, the function f of x equal to 100 is a constant function. So by the constant rule, the f prime of x, or the derivative of the function f, is 0. Another example. We have here our function y is equal to pi, another constant function. So by the first rule, y prime is equal to 0. Okay. For our second differentiation rule, which is the power rule, it states that if n is a real number, then the derivative of the function f of x in the form x to the n is equal to n times the quantity x to the n minus 1. So basically, what you need to do here in the power rule is just copy the exponent n and write it as a coefficient of the term, and at the same time subtract 1 from the exponent. Okay, say for example, our function f of x is equal to x to the 6. In this case, our exponent here is 6. So to get the derivative of the function f, or the f prime of x, is equal to write the exponent 6 as a coefficient of the term and subtract 1 to the exponent. So we have here 6x to the 6x to the 6 minus 1. Simplify. So the derivative of the given function, or the f prime of x, is equal to 6x to the 5. Okay, what if your function is a rational function? So we have here y is equal to 1 over x cubed. So first thing that you need to do here is you need to rewrite the given function in the form x to the n, and take note that 1 over x cubed can be written as x to the negative 3. So we can now apply the power rule for this given function, wherein our exponent is negative 3. So y prime is equal to copy negative 3 as a coefficient of the term, and at the same time subtract 1 to the exponents. We have negative 3x to the negative 3 minus 1. Okay, simplify. So you have y prime is equal to negative 3 x to the negative 4. Then applying the law of negative exponent, the derivative of the given function is equal to negative of 3 over x to the 4. Okay. For our next example, what if the given function is a radical function? So our function here, y is equal to the square root of x. Same as with the example 4, we need to rewrite the given function into the form x to the n, and take note that the square root of x can be written into a fractional exponent x to the 1/2. So our function now is y is equal to x to the 1/2. In this case, our exponent is 1/2. So to get the derivative of the function, copy the 1/2, copy the exponent 1/2 as a coefficient of the term, and subtract 1 to the exponent. So you have 1/2 x to the 1/2 minus 1. Then simplify. 1/2 minus 1, that's negative 1/2. So you have y prime is equal to 1/2 x to the negative 1/2. And by law of negative exponent, y prime is equal to 1 all over 2x to the 1/2. Then that's equal to 1 all over 2 square root of x. Okay, Now, for our third differentiation rule is a constant multiple rule, and it states that if the given function f is differentiable and c is a constant, then the derivative of the function c times the function f is equal to the constant times the derivative of the given function, or the constant times the f prime of x. Okay, say for example, our given function f of x is equal to 3x to the 5. So in this case, our constant is 3, then another function x to the 5. So to get the derivative of the given function in this case, we will just copy 3 and multiply 3 to the derivative of x to the 5, applying the power rule, and the derivative of x to the 5 is 5x to the 5 minus 1. So hopefully you can still remember the process in the power rule. Simplify. Our f prime of x is equal to 3 times 5x to the 4, then multiply 3 times 5, that's 15. So we have here the derivative of the given function is 15x to the 4. Okay, another example. So our given function here is 3/4 x to the 8. So first thing that you need to do to get the derivative of the given function, you copy first the constant and multiply the constant 3/4 to the derivative of x to the 8, applying the power rule, and the derivative of x to the 8 is 8x to the 8 minus 1. Simplify, so we have 3/4 times 8x to the 7, then multiply 3/4 times 8, that's 6. Thus, the derivative of the given function f of x is 6x to the power of 7, or 6x raised to 7. Okay. Next, differentiation rule, the sum or difference rule. And it states that let f and g be differentiable functions, then the sum or the difference of the function f and g is also differentiable. Thus, the derivative of the sum or the difference of the functions f and g is given by f prime of x plus for sum minus for difference g prime of x. So basically what you need to do here is get the derivative of the given function term by term. Okay, say for example, we need to get the derivative of the function f of x, which is equal to x cubed plus 4x squared minus 6x plus 1. So basically our given function here has 4 terms. This is the first term, the second term, third term, and the fourth term. So to find the derivative of f of x, we need to get the derivative of each term. So the f prime of x is equal to the derivative of x cubed, applying the power rule, that's 3x to the 3 minus 1, and the derivative of 4x squared, applying the constant multiple rule, that's 4 times the quantity 2x to the 2 minus 1, and the derivative of negative 6x is negative 6 times 1x to the 1 minus 1, considering that the exponent of x here is understandable 1. Then the derivative of 1 applying the constant rule is 0. Okay, simplify the terms. 3x to the 3 minus 1 is equal to 3x squared, and 4 times 2x to the 2 minus 1 is 8x to the 1 minus 6x raised to 0, and simplify again. Thus 8x to the 1 is just simply equal to 8x, and negative 6x to the 0 is simply equal to negative 6, applying the 0 law of exponents. Any number raised to the power of 0 is basically equal to 1. Thus, the derivative of the given function f of x is 3x squared plus 8x minus 6. Okay. So another example, applying the sum or difference rule. Our given function here is 4x squared minus 2 over 3x. So, before we will find the derivative of the given function, notice that the denominator of the given function is a monomial, which means that the expression can be written as a difference of two terms as follows. So our y is equal to 4x squared over 3x minus 2 over 3x. Simplify our given function. The 4x squared over 3x is basically equal to 4 over 3x, and just copy minus 2 over 3x. Then to apply the basic differentiation rule for 2 over 3x is we will rewrite the 2 over 3x into 2 over 3x to the negative 1. Then applying the difference rule, we will get the derivative of each term. The y prime here, the derivative of 4 over 3x, applying the constant multiple rule, is basically equal to 4 over 3 or 4/3. And the derivative of minus 2/3 x to the negative 1 is minus 2/3 times the derivative of x to the negative 1, because in this case the 2/3 here is the constant, so we will just copy the constant before we will multiply it to the derivative of x to the negative 1. Applying the power rule, the derivative of x to the negative 1 is negative 1 x to the negative 1 minus 1. Copy the exponent negative 1 as a coefficient of the term and subtract 1 to the exponent. So we have here negative 1 x to the negative 1 minus 1 as the derivative of x to the negative 1. Simplify. That's 4/3. Negative 2/3 times negative 1 is positive 2/3. X to the negative 1 minus 1 is x to the negative 2. Then applying the law of negative exponents, this is thus the derivative of the given function is 4 over 3 plus 2 over 3x squared. Okay. Our last differentiation rule is the product and the quotient rules. So, unlike the sum and difference rules, the derivative of the product or the quotient of two functions is not equal to the product or the quotient of their derivatives. In fact, the product and the quotient rules may be developed through the addition and subtraction of the same quantity. Okay, to fully understand the concept and how to get the derivative of the given function applying the product and quotient rule, is we will discuss the rule separately. So let me discuss first the product rule. The product rule states that let f and g be differentiable functions. It follows that the product f times g is also differentiable, and its derivative is given by f of x times g prime of x plus g of x times f prime of x. So basically, the rules tells us that the derivative of the product of the two functions f of x and g of x is equal to the sum of the product of f of x and the derivative of g of x and the product of g of x and the derivative of f of x. And for you to as easily understand the steps in solving the derivative using the product rule is just to remember this mnemonic. The first, the second, plus second, the first. First stands for the first factor. So in this case, our first factor is f of x. Second stands for the second factor. In this case, the second factor is g of x. Again, the mnemonic for the product rule is first, the second, the first. Okay. Say for example, our given function y is equal to 4 minus 2x cubed plus 2x plus x cubed. So in this case, our first factor is the quantity 4 minus 2x cubed, and the second factor is 2x plus x cubed. To get the derivative of the given function, applying the product rule is I will use the mnemonic first the second plus second the first. Okay, first the second. So copy the first factor, okay, times the second, meaning the derivative of the second factor. And the second factor is 2x plus x cubed. So the derivative of 2x plus x cubed plus second the first, meaning copy the second factor, 2x plus x cubed, times the derivative of the first, the derivative of 4 minus 2x cubed. Okay? Then perform the differentiation rule to get the derivative of 2x plus x cubed and the 4 minus 2x cubed. So our y prime is equal to, copy the first factor, and the derivative of 2x plus x cubed is 2 plus 3x squared, plus copy the second factor, and the derivative of 4 minus 2x cubed is negative 6x squared. Then multiply first, quantity 4 minus 2x cubed times the quantity 2 plus 3x squared, that's equal to 8 plus 12x squared minus 4x cubed minus 6x to the 5. Then multiply the second, 2x plus x cubed times negative 6x squared, that's negative 12x cubed minus 6x to the 5. Then combine like terms. Therefore, the derivative of the given function is negative 12x to the 5 minus 16x cubed plus 12x squared plus 8. Again, to solve for the derivative of the function, applying the product rule, just remember the mnemonic, first the second plus second the first. And the last differentiation rule is the quotient rule. So let f and g be differentiable functions. The quotient of f and g is also differentiable at all values of x, and its derivative is given by g of x times f prime of x minus f of x times g prime of x all over g of x squared. Basically, the rule tells us that the derivative of the quotient of two functions, f of x and g of x, is equal to the difference of the product of g of x and the derivative of f of x, and the product of f of x and the derivative of g of x divided by the square of the g of x. Same as with the product rule, for you to remember the steps in applying the quotient rule, just remember this mnemonic. Low d high minus high d low all over low squared. Basically, the high refers to the numerator, the low refers to the denominator. So once again, the mnemonic for the quotient rule, low d high minus high d low all over low squared. Okay, so let's apply the quotient rule in getting the derivative of the function h of x, which is equal to 2x squared plus 1 all over x minus 1. So applying the mnemonic, our high or the numerator is 2x squared plus 1. The low or the denominator is x minus 1. And the derivative of the given function, h or the h prime of x is equal to, again, the mnemonic is low d high minus high d low over low squared. Okay, first, low d high, copy the low times the derivative of the high minus the high times the derivative of the low all over low squared. Then, perform the differentiation rule for the 2x squared plus 1 and x minus 1. So we have here, copy first the low. The derivative of high or the derivative of 2x squared plus 1 is 4x minus copy the high. And the derivative of x minus 1 is 1 all over low squared. Okay, simplify. We have here 4x squared minus 4x, the product of x minus 1 times 4x, minus the product of 2x squared plus 1 is negative 2x squared minus 1 all over the quantity x minus 1 raised to 2. Okay, simplify again, combining like terms for the numerator. The simplified form for the numerator 4x squared minus 4x minus 2x squared minus 1 is 2x squared minus 4x minus 1. Then just copy the denominator quantity of x minus 1 raised to 2. Thus, the derivative of the given function h of x is 2x squared minus 4x minus 1 all over the quantity x minus 1 raised to 2. So once again, the mnemonic for the quotient rule is low d high minus high d low all over low squared. To sum it up, these are the key points to remember in solving for the derivative of the function applying the basic differentiation rule. These are the formulas for the constant rule, for the power rule, for the constant multiple rule, for the sum or difference rule, for the product, and this is for the quotient. Okay, I hope that you learned something today, and see you on our next video. By the way, for our next video discussion is we will tackle more illustrative examples in solving the derivative of the given function or the derivative of the function. So with that, have a nice day everyone, and see you on our next video.